living 14,000 years didn't make me a genius. I just had time. Time. We can't see it again here.
Okay, so this question asks us to parameterize the intersection of the surfaces y squared minus z squared equals x minus 2 and y squared plus z squared equals 9, using t equals y as the parameter. So they give us already that we're supposed to set all of the y's equal to t, and then we're going to make t our parameter variable. So let's do so. So we have t squared minus z squared equals x minus 2. And then the second one is rephrased as t squared plus z squared equals 9. Okay, so at this point, and kind of just speaking in general about finding intersection between surfaces, what you're going to do when you're given two equations is basically take one of them. So in this case, I'll start with the right one. And we're going to solve for one of the variables that we want that exists in the other equation that pops up there. So whatever we see, so what we're going to do is take, let's just find z by itself on the right side here, okay? And then whatever we solve for z, or whatever we find that z equals, we're going to plug it into the left equation here, okay? And then we're going to solve for x, basically. Okay, we already know that y equals t, because we're using that as our parameter, and now let's solve for z. So we're going to have to subtract the t squared from both sides. So we get z squared is equal to 9 minus t squared. And then we have z, if we square root both sides, what we get is a plus or minus square root of 9 minus t squared. Okay, so we solve for z. This is what our z component is going to be. And now let's plug it into the left equation. So we have t squared minus z. So in for the z spot, we're putting plus or minus radical 9 minus t squared. And then squared, right, that comes from this formula, equals x minus 2. So now at this point, we're kind of just narrowing it down so that we get x in terms of t, okay? So then we have a t squared minus, and then the square root and the squared cancel, so we have a minus 9 minus t squared is equal to x minus 2. We're going to distribute this negative, so we get t squared minus 9 plus t squared equals x minus 2. We can add 2 to both sides, and then we combine those, so we get that 2t squared minus 7 is equal to x, okay, because those cancel out there. Alright, so now we found x in terms of t, and I'll write down our conclusions on the next slide. So we found our x to be, or our x, aka x of t, our parametric equation, to be 2t squared minus 7. Our y was, or our y of t, was given as t, right? That's what the question told us to do. And our z, or our z of t, is, we found that to be plus or minus square root of 9 minus t squared. Okay, so at this point, what we're going to do is either, what you can do is both things. We can just write them down as this. So one way to write them, so method 1, we could write our answer as r of t is equal to, and just simply list these. So 2t squared minus 7, t, and then plus or minus square root of 9 minus t squared. And then we would have to list our domain, of course, for t, because we do have this restriction here given by the radical sign. So t must be in between -3 and 3, right, for that to be even possible, okay? So this is our domain there. Or we could do it a second way and just list it as r1, r sub 1 of t is equal to, and we'll just list everything as you see above, okay? But this time we're just going to pick like the positive square root, okay, for one of them, and we can say and these two go along with each other. They're both the answer, or like both of them make up the answer, the complete answer. So, and then we have the negative one down here, okay? So we basically just split it up into two curves if you want to do that instead. So you could list it as either one, and then again we have our domain restriction here, okay, given by the, or induced by the square root sign. Okay, so this is the first way to do it. You could list it like that, or the second way if you want to just break it down into the positive square root and the negative square root. Okay, so this again, it was the we just parameterized the intersection of the two given surfaces from the beginning. Okay, all right, so I hope that helped, and good luck and happy studying.